Hello student, welcome to the lecture on project management and masterpieces of facility planning, and after this lecture we will be able to learn the following objective. Discuss about network analysis, describe the network models CPM, PERT, comparison of CPM and PERT, explain network crashing. Let's start with the concept of project management and masterpieces of facility planning. Many people and organizations today have a new or renewed interest in project management. In the past, project management primarily focused on providing scheduled and resource data to top management in just a few industries such as the military and construction industries. Today's project management involves much more, and people in every industry and every country manage projects. New technologies have become a significant factor in many businesses, and the use of interdisciplinary and global work teams has radically changed the work environment. Facilities planning determine how an activity is tangible. Fixed assets best support achieving the activity's objective. This includes activities such as facility location, facility design, facilities layout, or plant layout. Facilities planning can increase plant productivity and reduce costs by reducing or eliminating all activities that are unnecessary or wasteful. A facilities design should accomplish this goal in terms of material handling, personnel and equipment utilization, reduce inventories, and increase quality. Let us now discuss the network analysis. Network is a graphical representation of all the activities and events arranged in a logical and sequential order. Network analysis plays an important role in project management. A project is a combination of interrelated activities, all of which may be executed on a certain order for its completion. Network analysis is the general name given to certain specific techniques which can be used for the planning, management, and control of projects. One definition of a project is a temporary endeavor undertaken to create a unique product or service. This definition serves to highlight some essential features of a project. It is temporary, it has a beginning and an end, it is unique in some way. Typically, all projects can be broken down into separate activities, tasks, or jobs where each activity has an associated duration or completion time, that is the time from the start of the activity to its finished. Precedence relationship, which govern the order in which we may perform the activities. Example, in a project concerned with building a house, the activity erect all 4 walls must be finished before the activity put roofed on can start. Importance of network analysis. The rapid growth of consumer data combined with the expanding impact of social media has created a need to better understand which data is meaningful. This is possible only when data is considered in the context of networks in which data is shared. Consideration of how people are connected to other people, places, and things help define the sphere of influence and can provide increased insights as to the nature and importance of transactions they conduct. Social network analysis. Every kind of social aggregation can be represented in terms of units composing this aggregation and relation between these units. This kind of representation of a social structure is called social network. In a social network, every unit, usually called social actor, a person, a group, an organization, a nation, a block, and so on, is represented as a node. A relation is represented as a linkage or a flow between these units. A set of possible relation is potentially infinite. The term relation can have many different meanings: acquaintance, kingship, evaluation of another person, the need of a commercial exchange, physical connection, the presence in a web page of a link to another page, and so on. Types of studies. The range of use of the idea of social network is very comprehensive, but there is a general agreement about the presence of 2 main classes of conceptions about the role of social networks. The main idea in the first class of studies is based on the link between properties and behaviors of an individual and the environment in which he is located. In a first kind of research, SNA has been used as a tool to explain individual behavior. In the second kind of studies of this kind, it has been proposed to use the structure of the relationship of the member of a group in order to understand the social collective behavior of a group. Sampling and boundary specification. Types of network. A network necessarily consists of a finite set of actors. This is due to two reasons. On one hand, this could be due to some restriction on the object under observation. For example, the interest of a researcher is a survey of the social structure of a small village or a classroom. On the other hand, this is mainly due to analytical requirement. So the problem is how to sample a group representative of the population and how to set the constraints of this sample. Rules for drawing network. The following rules are all logically based and should be thoroughly learned before attempting to draw networks. A complete network should have only one point of entry, a start event, and only one point of exit, a finish event. Every activity must have one preceding or tail event and one succeeding or head event. Note that many activities may use the same tail event and many may use the head event. However, an activity must not share the same tail event and the same head event with any other activities. No activity can start until its tail event is reached. An event is not complete until all activities leading in it are complete. This is an important rule and invariably has to be applied in examination question. Loops, that is a series of activities which lead back to the same event, are not allowed because the essence of network is a progression of activities always moving onwards in time. All activities must be tied into the network, that is, they must contribute to the progression or be discarded as irrelevant. Activities which do not link into the overall projects are termed danglers. Now moving on to the next topic, we will study the models, CRM or PERT. One of the most challenging jobs that any manager can take on is the management of a large-scale project that requires coordinating numerous activities throughout the organization. A myriad of details must be considered in planning how to coordinate all these activities, in developing a realistic schedule, and then in monitoring the progress of the project. Fortunately, two closely related operation research techniques, PERT, Program Evaluation and Review Technique, and CPM, Critical Path Method, are available to assist the project manager in carrying out these responsibilities. These techniques make heavy use of networks to help plan and display the coordination of all the activities. They also normally use a software package to deal with all the data needed to develop schedule information, then to monitor the progress of the project. The PERT and CPM has been used for a variety of projects, including the following types: construction of a new plant, research and development of a new product, NASA space exploration projects, movie production, building a ship, government sponsored project for developing a new weapons system, relocation of a major facility, maintenance of a nuclear reactor, installation of a management information system. Original versions of PERT and CPM had some important differences, as we will point out later. However, they also had a great deal in common, and the two techniques have gradually merged further over the years. In fact, today, software packages often include all the important options from both original versions. The procedure is as follows. Define the project and all of its significant activities or tasks. Develop the relationship among the activities. Decide which activities must proceed and follow others. Draw the network connecting all of the activities. Assign time or cost estimates to each activity. Compute the longest time path through the network. This is called critical path. Use the network to help plan, schedule, monitor, and control the project. Brief history of CPM or PERT. The CPM or PERT or network analysis as a technique is sometimes called developed along two parallel streams, one industrial and other military. The CPM was a discovery of M.R. Walker of E.I. DuPont D. Nemours and J.E. Kelly of Remington Rand Kirka, 1957. The computation was designed for the UNIVAC-1 computer. The first test was made in 1958 when CPM was applied to the construction of a new chemical plant. In March 1959, the method was applied to maintenance shutdown at the DuPont worked in Roosevelt, Kentucky. Unproductive time was reduced from 125 to 93 hours. The PERT was devised in 1958 for the POLARIS missile program by the Program Evaluation Branch of the Special Projects Office of the U.S. Navy, held by the Lockheed Missile System Division and the consultant firm of Booz Allen and Hamilton. The calculation was so arranged so that they could be carried out on the IBM Naval Ordnance Research Computer (NORC) at Dell Grunt, Virginia. Planning, scheduling and control. Planning, scheduling or organizing and control are considered to be basic managerial function, and CPM or PERT has been rightfully accorded due importance in the literature on operations, research and quantitative analysis. Far more than the technical benefit, it was found that PERT and CPM provided a focus around which managers could brainstorm and put their ideas together. It proved to be a great communication medium by which thinkers and planners at one level could communicate their ideas, their doubts and fears to another level. Most important, it became a useful tool for evaluating the performance of individuals and teams. There are many variations of CPM and PERT which have been useful in planning cost, scheduling manpower and machine time. The CPM or PERT can answer the following important question. How long will the entire project take to be completed? What are the risks involved? Which are the critical activities or tasks in the project which could delay the entire project if they were not completed on time? Is the project on schedule, behind schedule or ahead of schedule? If the project has to be finished earlier than planned, what is the best way to do this at the least cost? Critical path analysis (CPA), network analysis. Critical path analysis (CPA) is a project management tool that sets out all the individual activities that make up a larger project, shows the order in which activities have to be undertaken, shows which activities can only take place once other activities have been completed, shows which activities can be undertaken simultaneously, thereby reducing the overall time taken to complete the whole project, shows when certain resources will be needed, for example, a crane to be hired for a building site. In order to construct a CPA, it is necessary to estimate the elapsed time for each activity, that is the time taken from commencement to completion. Then the CPA is drawn up based on the dependencies such as the availability of the labor and other resources, lead times for delivery of materials and other services, seasonal factors such as dry weather required in a building project. Once the CPA is drawn up, it is possible to see the critical path itself. This is a route through the CPA which has no spare time, called float or slack in any of the activities. In other words, if there is any delay to any of the activities on the critical path, the whole project will be delayed unless the firm makes other changes to bring the project back on track. The total time along this critical path is also the minimum time in which the whole project can be completed. Some branches on the CPA may have float, which means that there is some spare time available for these activities. Steps in CPM project planning. Specify the individual activities, determine the sequences of those activities, draw a network diagram, estimate the completion time for each activity, identify the critical path, longest path to the network, update the CPM diagram as the project processes. Update the CPM diagram as the project progresses. As the project progresses, the actual arcs, completion times will be known and the network diagram can be updated to include this information. A new critical path may be emerged and structural changes may be made in the network if project requirements changes. CPM limitation. The CPM was developed for complex but fairly routine projects with minimal uncertainty in the project completion times. For less routine projects, there is more uncertainty in the completion times, and this uncertainty limits the usefulness of the deterministic CPM model. An alternative to CPM is the PERT project planning model, which allows a range of duration to be specified for each activity. Program Evaluation and Review Technique, PERT. Program Evaluation and Review Technique, PERT, is another derivative of the GANTT chart. Multiple time estimates were used for each activity that allowed for variation in activity times. Activity times are assumed to be random with assumed probability distribution. Probabilistic activities are represented by arrowed lines between the nodes or circles. The PERT networks are developed around two key concepts: activities and events. An activity represents a task or sub-project that uses time or resources. It is represented by an arrow. An event is an indication of the beginning and or ending of activities in the network. It is denoted by a circle which contains a number that helps identify its location. In constructing a PERT network, manager must first develop a list of the major activities that are involved in the project and then determine which activities must precede others. The next step is constructing a network diagram, a graphic depiction of the interrelationship among activities. So far we have talked about projects where there is high certainty about the outcomes of activities. In other words, the cause-effect logic is well known. This is particularly the case in engineering projects. However, in research and development projects or in social projects, which are defined as process projects, where learning is an important outcome, the cause-effect relationship is not so well established. In such situation, the PERT approach is useful because it can accommodate the variation in event completion times based on an expert or an expert committee's estimates. Determine activity sequence. This step may be combined with the activity identification step, since the activity sequence is evident for some tasks. Other tasks may require more analysis to determine the exact order in which they must be performed. Construct a network diagram. Using the activity sequence information, a network diagram can be drawn showing the sequence of the serial and parallel activities. For the original activity on arc model, activities are depicted by arrowed lines and milestones are depicted by circles or bubbles. If done manually, several drafts may be required to correctly portray the relationship among activities. Software packages simplify this step by automatically converting tabular activity information into a network diagram. Let's note the meaning of comparison of CRM and PERT. Project management has evolved as a new field with the development of two analytic techniques for planning, scheduling, and controlling projects. These are the CPM and the PERT. The PERT and CPM are basically time-oriented methods in the sense that they both lead to the determination of a time schedule. Basic difference between PERT and CPM. Though there are no essential differences between PERT and CPM, as both of them share in common the determination of a critical path, both are based on the network representation of activities and the scheduling that determines the most critical activities to be controlled so as to meet the completion date of the project. PERT. The PERT was developed in connection with an R&D work. Therefore, it had to cope with the uncertainties that are associated with R&D activities. In PERT, the total project duration is regarded as a random variable. Therefore, associated probabilities are calculated so as to characterize it. It is an event-oriented network because in the analysis of a network, emphasis is given on the network stages of completion of a task rather than the activities required to be performed to reach a particular event or task. The PERT is normally used for projects involving activities of non-repetitive nature in which time estimates are uncertain. It helps in pinpointing critical areas in a project so that necessary adjustment can be made to meet the scheduled completion date of the project.
We're going to discuss a PERT chart or a network analysis chart. PERT is Program Evaluation Review Technique, and this is used to sort out relationships in a project where start-finish dates and working out a critical path for your project. Items on the critical path, if any is delayed, your project will be delayed. Going into this PERT chart that I have set up in front of us, task A is 1 day, task B is 1 day, task D is 1 day, task F is 1 day, and task C and E are both 2 days. The diagram that is shown here is in PERT chart format or network analysis, where they are all drawn the same size and all the information is in each particular box. Given the colours of this chart, I've written above them what the task name is, in which case this is A, B, C and so on, and the duration in the corner. The items shown here, this will start on Monday, the 1st of August 2011. This task will take 2 days, so that is Tuesday and Wednesday, the 2nd and 3rd of August 2011. The next one, task E, is 2 days, so that will be on the 4th and 5th of August 2011. And because we don't work weekends, the last task is done on Monday, the 8th of August 2011. These 2 tasks are only 1 day each. They can be programmed in this situation anywhere as long as both this task and this task are completed prior to starting task F. So we have the bottom line here is our critical path for this project. Anything on that project extends, it will affect the end date of the project. If this wasn't done until the 6th, this could not be done, the 6th is a Saturday, you may do that Monday, but if this wasn't done till Monday, you couldn't do that till Tuesday. So anything on this red line that is extended will extend the length of the project. This chart is a network analysis chart or a PERT chart, Program Evaluation Review Technique.
CPM. The CPM was developed in connection with a construction project which consisted of routine tasks whose resource requirements and duration were known with certainty. Therefore, it is basically deterministic. The CPM is suitable for establishing a trade-off for optimum balancing between schedule time and cost of the project. CPM is used for projects involving activities of repetitive nature.
Critical path method, also known as critical path analysis. It is a mathematically based method that is useful in help to determine an efficient schedule for the task or any project activities. It is an important tool for project management. The critical path method is one of the techniques for doing project planning. CPM is for projects that are made up of a number of individual activities, especially when some of the activities require other activities to finish before they can start. Critical path method can help in figure out how long the entire complex project will take to complete. It also tells us which activities are critical. The word critical means that they have to be done on time, or else the project will take longer time. Now, I will show you the example of how to apply the critical path method into practical. This is an example of question for critical path method. Task ID means the symbol that represents each activity. Duration means the times needed to finish each activity. And dependency means the next activity after finish the previous activity. First, we have to find out the earliest start and earliest finish for every activity. We count the earliest start by starting with 0, and then add on the duration for each activity to become the number of earliest finish. Then continue to find earliest start to end earliest finish for all the activities. After adding the earliest start and earliest finish, it is time to find out the latest finish and latest start. Latest finish means the latest time for each activity to be completed, and latest start means the latest finish time minus the duration of completing the activity. Finally, we can already know which is the critical path after we calculate the earliest start and latest start. Critical path is the path that we just lack, which means that the time of earliest and latest start are the same. When the activities are critical, any delay to them will delay completion of the whole project.
Crashing refers to a particular variety of project scheduled compressions which is performed for the purpose of decreasing total period of time, also known as a total project schedule duration. The diminishing of the project duration typically takes place after a careful and thorough analysis of all possible project duration, minimizing alternatives in which any and all methods to attain the maximum schedule duration for the least additional cost. The objective of crashing a network is to determine the optimum project schedule. Crashing may also be required to expedite the execution of a project irrespective of the increase in cost. Now in the end, let us summarize what we have learned in this lecture. The additional labor and resources increase the project cost. Total project costs include both direct costs and indirect costs of performing the activities of the project. The total cost of project, which is aggregate of the activities cost, will also depend upon the project duration. In the realist approach, subjects have some kind of shared knowledge of the network as a social entity. The objective of the facilities planning are to support the organization vision to improve material handling, material control, and good housekeeping.